All right, so this is the second one, the one you took. Most of you didn't get to start, so let's get right away. So this one, I have to like squeeze in things. So order of operations dictates that I do 12 minus 4 first and then times 3, so it's 46 minus 12 divided by 4 is 3 times 3 plus 20. I still have to take care of the multiplication, so it's 46 minus 3 times 3 is 9, and then plus 20. 46 minus 9 is like, I don't know, let's say 35, and then plus 20. So first answer to the first question is 55. Just 50 questions. Okay, so second one, let's take care of the parentheses because those are unknown values, right? This is parentheses represents an unknown value, and this second parenthesis also represents another unknown value. So let's find out what that unknown value is. So 4 divided by 4 is 1 times 4, and then plus, in this parenthesis we have 4 to the second power. 4 to the second power is the same thing as 4 times 4. So that's 16, and then 16 minus 4, it's going to give us 12. So that parenthesis all boils down to 12. Order of operations now, I have to do multiplication. So 1 times 4 is 4, plus 12 equals 16. So that was not that bad. 3. I have a multiplication, I have division and subtraction, so I'm going to take care of this multiplication, and then the division, subtraction for last. 2 times 36 is 72. Minus 24 divided by 6 is like 4. And 72 minus 4 is 68. So that was simple. Again, let's take care of the, what is this called? The parentheses. 23 minus 9 is 21, which I'm going to multiply to 3 and then add 5. Multiplication comes first, so 21 times 3 is 63. Plus 5 equals 68. Number 5. I'm going to take care of the parentheses, 10 plus, and inside the parentheses, let's see if we can do it all at once. 5 times 4 is 20. And then 20, I'm going to subtract 12, right? 20 minus 12 is 8. Times 2 to the second power is 4. So now I got two operations. I got a plus here and a multiplication here. So let's do the multiplication. 10 stays, the plus sign stays, and 8 times 4 is 32, which is going to give us 42. 6, it's going to be exponents here, so we have to take care of that. So 87 minus 6 plus 9 divided by 3 to the second power is 3 times 3, which is 9. Now that all my unknown values have become numbers, I can do the operations, subtraction, addition, division. So we're going to take care of the division. And 9 divided by 9 is 1. So now I can do addition, subtraction, left to right. 87 minus 86 is 81. And then plus 1 equals 82, right? 7, write an expression with two operations that's simplified. So we're going to come up with an expression. Make one up. Use a combination of division, multiplication, addition, subtraction. You should have two of these. And whatever that is, it should equal to 1. So one simple one. Let's do 5 times 4 minus 19. Does that equal to 1? Well, 5 times 4 is 20, and if I subtract 19, that is definitely equal to 1. So you can make a bunch of ones that you can work out that it equals to 1. So that was just an example of mine. Okay. That wasn't that bad. 7, 43 to go. 8. The expression 7 times 4 and 4 times 7, example of what property? Well, that one is the commutative property. Commutative property of what? Multiplication. Commutative property of multiplication. Multiplication. Okay, sorry about the handwriting. 9. This one, okay, as you can tell, it's distributive property, right? Because 3 times 2 is here, plus 3 times 5. So this one, I'm just going to abbreviate distributive property. Distributive property. P times Q times R. So we have to do P times Q first because it's in parentheses. On this side, instead of that, we do Q times R. So this is definitely the associative property. 11. 42 times 1 equals 42 is an example of which property? This one we didn't talk about, but this is the identity property of multiplication. Identity property. Okay, so anything times 1 is just that number, right? So it's the identity property of multiplication. Okay, so that's not a big deal, even though we didn't go over in class. It's one of the properties. 12, multiple choice. Which one is an example of community property? Community multiplication. So this is addition, garbage. This one has parentheses, so that means associative property, so that's garbage. 12 times 1 is 12. It's not. That's the identity property, which we just did here. So 4 times 8 and 8 times 4. This is the one you're looking for. This one, 284 plus 0 equals 284. It's not commutative, right? Because otherwise here you would say 0 plus 284. That's that. It's not associative. And even if you didn't know what it was, you know what a commutative is, and that's not it. It's not associative. It's definitely not distributive. So this is called the identity property of, is it called of addition or of 0? So any number added to 0 equals that particular number. So it's definitely, again, the identity property. I'll get back to you on that one, okay, as to the complete name. And last one, this is, again, let's see, it has parentheses, a factor outside, so it's 1 times 3, which is here, plus 1 times 7, which is here. So this is definitely the distributive property. All right, so it's not that bad, says me. Huh. Okay, so over here, let's go. So we got a, what do you call? We got to substitute. Z equals 5, so we got to go C 6 times 5 to the second power divided by 3 times 5. Let's do the exponents first. So it's 6 times 5 to the second power is 5 times 5, which is 25. Please don't multiply 6 and 5 together. You gotta get rid of the exponents. Divided by 3 times 5, which is 15. 6 times 25 is, I don't know, like 150. And divided by 15, so this one becomes easy. 150 divided by 15 is just simply 10. 16, 9 times p, which is 3, plus 11. This one is super easy. That's 27 plus 11, which equals 38. 17, 4, and t in this case is 10, so it's 4 times 10 to the second power divided by 10. Take care of the exponents first. 4 times 10 to the second power is 100. I'm going to divide that by 10. 4 times 100 is 400. And if we divide that by 10 equals 40. Yeah? 8 plus p, which is 4 to the second power, minus 3 times c, which is 2. Let's get rid of the exponents. 8 plus 4 to the second power is 16 minus, and actually we can do this, 3 times 2 is 6. Do it from left to right. 8 plus 16 is 24 minus 6, and 24 minus 6 is 18. Final answer. Minimum wage set in 1997 was $5.50, 15. So $5.15 per hour times however many hours you work. If you work 1 hour, 1 times 5.15 is 5.15. If you work 2 hours, it would be 2 times 5.15 would be cheap. It would be 10.30, right? And so forth, so forth. So evaluate the expression 40h, where h equals 5.15. So it's going to be 40, and we have 40h, and we know that h is, according to this, $5.15. We got to multiply 40 times 5.15. Let's multiply that times 40. I have 2 decimal places over here, so I'm going to write 2 decimal places. There's 0 decimal places over here. So combine my 2 numbers being multiplied, have 2 decimal places, and that's going to tell me how many decimal places my answer should have. So 0 times 5 is 0, 0, 0. Let's add a 0 as a placeholder. 4 times 5 is 20, carry 2. 4 times 1 is 4, plus 2 is 6. 4 times 5 is 20. We're going to add 0, 0, 6, 0, 6. 2 decimal places, right? So we're going to put it, so let me just write this so that you can see. This is what we have. We're going to put 2 decimal places, so count from here. 1, 2, 1, 2, and we put a decimal right here. So the final answer is $206. It's right there. Okay. Um, 21, write an expression. Okay. Translating words to algebra. So 4 is 4. More than means addition. A number multiplied by 3. So there's your answer. But let's clean that up. That's better written like this. 4 plus, and remember, anytime we have a number and a variable here being multiplied to each other, we want to write the coefficient first and then that. So if you had left it like this, it would have been okay, but this would be just the prettier version. 22, how would you write a phrase that represents the expression 2x plus 4? So it'd be 2 times a number. Let's keep that very simple. 2 times a number plus 4. Ta-da! 23, how would you write the phrase that represents the expression 3 times, so it's 3 times, what are we multiplying the 3 by? We're multiplying 3 times, and what's happening here is the sum, right? 3 times the sum of a number and 9. Remember, we have to figure out what the parentheses is and then multiply by 3. Okay, so therefore, we have to find the sum first and multiply by 3. Write an expression equivalent to the quotient of a number and 5 plus 2. So the quotient means division. What are we dividing? A number and 5 plus 2. Honestly, this one is the way it's written, it's probably incorrect. The quotient of a number and 5, there should be a comma here. It should be plus 2. There should be a comma. Okay. Next one. Which is an expression that shows the earnings of 23 hours a salary of $D per hour. So he worked $23, 23 hours. And you want to find out how much you make. So let's assume you work for 23 hours and you want to know how much, you made for that week. You would take your 23 hours and you will multiply that by what? By the number of hours you work, right? So we got multiply that, not the hours, multiply that by however much you get paid per hour. So it'd be 23 times D, right? If you work 23 hours, multiply that by however much you make, and you would get your paycheck, right? Definitely not division, addition. Okay, so it's definitely this guy right here. Pantheon in Rome has n granite columns in each row of in each of 3 rows. N granite columns in each of 3 rows. By an addition expression show the number of columns. In Rome has n granite columns. This is a column in each of 3 rows. This, I don't get it. We're skipping 26. Pantheon has n granite columns in each of 3 rows. Okay, I don't think grammatically that's correct, so we're going to skip 26. 27. Simplify. So this means combine like terms. There's a title, right? So who's your like term here? This is, and the minus x, and that one is different. So let's move the like terms together. So you got x, move this next, minus x, and then finally plus x squared. These two x's are like terms. The x squared is a different, right? Because so it's definitely different. So we can combine. So it's x minus x. X minus x is 0. Plus x squared, or just simply x squared. Yeah. Over here, it's a b squared, and this is also b squared. So those are like terms. Move them together side by side. 14b squared minus 2b squared, and then plus a. So let's combine. 14 minus 2 is 12. 12b squared plus a. 29 p's, p3. That's a p3. This is a p3, so it's minus p3. Q's, we have triangle. 12q, 3q. And the last thing, I'm not putting anything because there's no like term. So let's put all the p3's together. So 5p3 minus 2p3 plus 12q plus 3q, and finally plus 6. So I can combine these two. 5 minus 2 is 3, p3. The q's, 12 and 3 is 15 q's, and finally plus 6. 30, the side, so it's a triangle. Equilateral means all the sides are the same, so this is x plus 3. This is x plus 3. And this fell over here is x plus 3. So we want to find the perimeter. Let's add all the sides. X plus 3 plus x plus 3 plus x plus 3. Like terms, this x plus x plus x. So you're going to get x plus x plus x, which is 3x. And if you'd like, you can write a 1 over here. Right, 1x, 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 3x. And then 3 plus 3 plus 3 is 9. So that's fine. Again, you could have done it that way, or you could have used the distributive property and say 3. I have 3 of the same, right? 3 times x plus 3. And use the distributive property. 3 times x is 3x. And 3 times 3 is 9. And then you notice you get the same answer. 31, a hexagon is 6-sided. Find the perimeter of a hexagon with all the sides the same length. So you got a hexagon. So let me see. Hexagon has 6 sides. 1, 2, 3, 4, 5, 6. And each side is x plus y. X plus y, 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 x plus y. So you're multiplying this by 6 or adding this x plus y 6 times, right? So the easier way is to do this 6 times x plus y. Distributive property, 6 times x is 6x, and 6 times y is 6y. Or you could have written the expression x plus y plus x plus y plus x plus y 6 times, and then all your like terms are the x's, right? All the x's, you would have 1, 2, 3, 4, 5, 6 x's. And how many y's do you have? Adding this y plus 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 this y, you get 6y. They both lead you to the same answer. Perimeter again. So you got, so let's, 2a is a triangle, that's one side, plus 3c plus 7 plus 6a minus 4. So again, this a and this a is like term. So 2a plus 6a is 8a. 4c plus 3c, so we're adding these two, right? 4 plus 3 is plus 7c. And the last one, careful, is plus 7 minus 4, and 7 minus 4 would be plus 3. So your final answer is 8a plus 7c plus 3. 13. Use the figure below to solve the following questions. Okay, so let's figure out shows that write an experiment for the. So here's a garden, right? So we want to find the perimeter would be. Let's start with this guy. B plus a plus c plus a plus c. So combine the like terms, we can add the b with a plus b, and then get 2b. Then we have an a plus another a, and we got plus 2a, and c plus c is plus 2c. So combining all the like terms, that's what I get. The rectangle, the square is a square. So if that's a square, you know all the sides are the same. So that means this is b, this is b, and this is b. And the perimeter would be b plus b plus b plus b. If you like, you can put a 1 in front of every b. It's the same thing, right? So b plus b plus b plus b. How many b's do we see? 4 b's. That would be the perimeter of this shape. Now, part C says combine the perimeter of the pool and the garden. So here's the pool, 2b plus 2a plus 2b. sorry, 2b plus 2a plus 2c, and then we're going to add that to that. We're going to add the perimeter of the square poles, which is 4b. Can I combine anything? Yeah, I can combine now. The b was the b that was over here, so I can combine these two b's, right? 2b plus 4b is 6b, and the a's and c's have nothing or no one to add with, so just stay the same. And that would be our final answer. Fractions and decimals. Convert to a fraction in simplest form. Yucca. All right, so here it'd be 42 over, what's the decimal place here? What's the place value? This is the tens, the hundreds, and the 1,000. Did it say simplest form? Ugh. So it's 42 over 1,000. We can divide that by 2. If I divide 42 by 2, I get 21. If I divide 1,000 by 2, I get 500. Final answer, 21 over 500. Erase. I have to divide, I have to divide, I have to divide. Let me do the easy ones. So 2.07 will be 2. Actually, you know what? I'll do it this way. That's 207 over, what's the place value? 10, right? How many times can 10 go into 207? Sorry, 100. There's 100 place value. So 100 goes in 207 2 times, 7 left over 10. So that would be this one. 0.6, hopefully you know by now that that's 2/3. 2 divided by 3 is going to give a repeating decimal. Goes on and on and on forever and ever. And these 3 I actually have to divide. So I want you to go and divide 13 divided by 11, 5 divided by 8, and let's see, what would you get? 13 divided by 11. You would get, this one would be 1.181818. So this would be this. Second one would be 0.625. And the last one, 4 divided by 9, would get you 0.4444 forever and ever. So we're just 0.4 bar notation. Okay, so just you got just divide those, okay? And what do we have? 37. We're not that far off. Okay, so you know what? Let me pause this for a second. Okay, so we're on 37, I believe. So again, this one, you have choices. You can do it two ways. You can change everything to improper or not. If you don't change it to improper, you're going to have to regroup, because I know that 4/9 and 5/6 is definitely going to change to an improper fraction, a mixed number. So I'm going to alternate with these questions one way or the other one. So for this one, I will not change to what do you call improper fraction yet. So it becomes 7. The fractions, the LCM between 9 and 6 is 18. Plus 3 over something over 18. How did the 9 become 18? Times 2, so 4 times 2 is 8. 6 times 3 became 18, so 5 times 3 here is on top. Now I can add, right? So 7 and 3, my whole numbers is 10. My fractions, 8 plus 15 is 23 over 18. Again, here's the problem if you don't change it to improper fraction. You need to regroup. So 18 over 23, 18 goes into 23 one time. 5 left over, and no 18. So this is this part, right? This changes to that. So now I have this whole number 10 that I can't forget about. So the 10 and the 1 adds up, and I get 11 and 5 over 18. 38. 38. Now 38, and again, remember I said earlier, fractions like 1/5, 1/4, anything under 5 with denominator 5, 4, or tens, I think it's much easier if you change it to a fraction. Sorry, decimal. So 3 and 1/5, it becomes 3.2 plus 0.46. So, and if I add this, 3.2 plus 0.46, that's a 0 over here, right? Placeholder 6, 6, and a 3. Now, if you don't want to do that, and you want to change this to a fraction, so 3 and 1/5 stays, and 0.46 is 46 over 100, yeah? So now we have two fractions here, so I'm going to change the 1/5 into something equivalent fraction over 100. How did the 5 become 100 times 20? So on the top I multiply and I go times 20. So 1 times 20 is 20. So now I have 3 and 20th, which is the same thing as 3 1/5. And I add this to 46 over 100. I have nothing to add with my whole number, so I'm going to leave the 3. But my fractions is 100. And 20 plus 46 is 66, which can be simplified to 3. And I'm going to divide top and bottom by 2, so I get 33 over 50. Your choice. Now these two are decimals, are fractions, so I'm going to change them both to a fraction. Now, 4, 6 is, let's change that to something over 30, because that's the LCM, right, the smallest multiple that is in common. So this is already a 30, that stays. So how did the 6 become a 30? Times 5. That's times 5 over here is 25. So it becomes 4 25th over 30 minus 7 over 30. The 4, nothing to subtract. The whole numbers, there's no whole number here. But the fractions I can. So 25 minus 7 is 18. So it becomes 18 over 30, which I can simplify to 9 over, actually, let me divide this by 6. So if I divide 18 divided by 6, I get 3. 30 divided by 6, I get 5. So 4 and 3/5 is the final answer. Next one. This one, let's change everything to an improper fraction. 3 times 6 is 18 plus 1, so I get 19 over 6 minus 12 times 2 is 24 plus 7 is 31. 31 over 12. So this is a way of doing with improper fractions. 12 is the common multiple, smallest one. So that's already a 12, so nothing to worry about here. But 6 became a 12 times 2, so I must change the numerator times 2. So I get 38 over 12. Now I can subtract. 38 minus 1 is 7, and 12 stays the same. So this is my final answer. So this has its advantages too, okay, of doing it this way. Next one is multiplication. So actually, great. Multiplication, I have to change it to, don't multiply 3 and 2 and then, change them both to improper fraction. 3 times 8 is 24 plus 3, so I got 27 over 8 times 9 times 2 is 18 plus 2 is 20 over 9. Simplify before you multiply. There's definitely things you can simplify. 27 and 9, definitely you can do something about it. Let's divide 9 by 9. I get 1. 27 by 9, I get 3. 8 and 20, they're both even, so I definitely know I can divide by 2, but I can also divide them by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. Now there's nothing else to do. So 3 times 5 on the top is 15. 2 times 1 at the bottom is 2. 15 over 2, which is the same thing as 7.5, because 2 goes into 15 7 times, so there's 1 left over 2. Next one, 4 times 5 is 20, plus 3 is 23 over 20. Times, and I think I did something wrong. No, that's right. Times 6 times 1 is 6 plus 5 is 11 over 6. It's division, right? So that's division. Now I'm going to change that to multiplication. So it's 23 over 20 times 6 over 11. I can reduce 6 and 20. Divide this by 2, I get 3. Divide 20 by 2, I get 10. Is there anything else I can simplify? No. 23 times 3 is 69. 10 times 11 is 110. Final answer for 42. 43, that's 7/5. So, sorry, 5/7. Divided by, let's change that to a fraction. The 5 is in the hundreds place, so it's 100 over 75. And then I'm going to change that to multiplication, so it's 5 over 7 times 100 over 75. A lot of things you can do here. So let's simplify. I'm going to simplify the 175. I'm going to divide this 100 I'm going to divide by 25. 100 divided by 25 is 4. 25 divided by 25 is 3. Is there anything else I can do? No. 5 times 4 is 20. 7 times 3 is 21. And that takes care of that. 44. So I'm going to put 8 over 1. 8 times 1 on the top is 8. 1 times 4 is 4. And 8 over 4 is just 2. 45. Okay, 45 I have to subtract first and then divide. So let's ignore the 0.4 for a while. So let's divide and subtract inside. Different denominators. So I'm going to change everything to something over 10. Because that's what's the common multiple between 5 and 10. 7 over 10 already has a 10, so that no changes here. But the 5 did change to 10 times 2. Multiply the 4 times 2, and I get 8. Divided by 0.4. 8 minus 7 is 1, so I get 1 over 10 divided by 0.4. But I'm going to change the 0.4 to a fraction. And 4 is in the tens place, so it's just 4 over 10. Change that to multiplication. 1/10 times the reciprocal, 10 over 4. This one is nice. 10 divided by 10 is 1. 10 divided by 10 is 1. Now I can multiply and I get 1 over 4. 46. Ooh, okay. This one I changed to fractions only because 3 doesn't change to a nice decimal. Otherwise I would have changed to a decimal. So let's change it to fractions. 45 over 100 plus 1/3. Did I say change to a fraction or a decimal? Change to a fraction, right? 9 over 20. How do I change that to something over 100? So, sorry, that's going to be 100, right? So 20 times what's 100? It's times 5. So I'm going to multiply the 9 times 5. I get 45. Plus 0.2. The 2 is in the tens place, so it's 2 over 10. Yuck. Really? Oh, so this one, common denominator of all, the LCM between 100, 3, and 10, the thing is 300. I'm going to change everything to 300. Is that the easiest way to do it? Well, 100 times what's 3? Times 3, right? So on top it's going to be times 3. 45 times 3 is 45 plus 45 plus 45, which is 135. 3 times 100 is 300, so I'll multiply the top by 100, and 1 times 100 is 100. So far, so good. 100 to 300. How did 100 become 300? Times 3. And it's times 3 again, so it's 135. And the last one, how did the 10 becomes 300? It's times 30. So I'll multiply 2 times 30, and I get 60. So denominator is 300, so I'm going to do 135 plus 100 minus 135 plus 60. So 135 plus 100 is 235. 235 minus 135 is 100. And 100 plus 60 is 160. Let's divide top and bottom by 10. If I divide top and bottom by 10, I'm going to get 16 over 30. I can still simplify this. Divide top and bottom by 2. 16 divided by 2 is 8. 30 divided by 2 is 15. Final answer, 8 over 15. Ugh, yucky problem. And the last one. So this is a complex fraction, right? Remember, I believe we talked about this. So let's rewrite this in a way that's a little bit better to understand. So it's 7/8 minus a half. And this is a division bar, right? So this is division. Divided by 2 over 9. So I didn't change anything. So I just wrote this in this way because I think it's a little bit easier to understand. So let's do the parentheses here. We gotta do that parentheses 7/8 minus a half. So let's leave that behind. So 7/8, the LCM is 8. So I'm going to change both fractions to 8. Right? That's 7 over 8. And then how did the 2 become an 8 times 4? So I multiply the top by 4 and I get 4. That's in parentheses divided by 2 over 9. So 7 minus 4 is 3. And 8 stays the same. Now I'm ready to divide by 2 over 9. And 3/8, I'm going to multiply by 9 over 2. Is there anything to simplify? Oh, no. 3 times 9 is 27. 8 times 2 is 16. And 16 goes in 27 one time. And I have 9 left. No. 11 left. What am I doing? Yeah, 11 left over 16. Final answer. And finally, we have, oof, that's it. We're almost done. So he has a board. So his board is this long. It's 12 foot long. It's about twice my height. And he wants to cut them into smaller pieces, 1.5 foot, 1.5 foot, 1.5 foot, 1.5 foot, and so forth. So how many of these little smaller pieces can I have? So it's a division problem, yeah? So this is what I have, and I want to break it up into these many pieces, into pieces of this size. 12 over 1, let's change that to a fraction, divided by, and again, I'm going to change this to a mixed number, improper fraction. 2 times 1 is 2, plus 1 is 3, it's 3 over 2. Now I'm going to change that to multiplication. And this one, can I simplify anything? I can, the 12 and the 3. So they're both divisible by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. Now I'm ready. 4 times 2 is 8. At the bottom, 1 times 1 is 1, or 8 over 1, which is just simply 8. So how many little boards can I get out of a 12-foot long board? 8. 8 smaller 1.5 foot piece boards. 49, 21 pieces of candy. She gave 4/7 of her candy. How many pieces she gave away? All right, so imagine this for a second. You have 21 pieces of candy, and I say, I want to take 4/7 of what you have. So the operation would be multiplication. I want 4/7 of what you have. So I'm taking 4/7 of this. So imagine if this was all your lollipops, right? 4/7, you know, 4/7 is a little bit more than half, so I would take about this much away from you, right? So let's figure out what that much is. So 4/7 times 21, let's put this over 1. Is there anything we can simplify? Yeah, we can. 7 and 21, they're both divisible by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. We're ready? 4 times 3 is 12. 1 times 1 is 1. So 12 over 1 is the same thing as 12. So if you had 21 candies and I said I'm taking 4/7 of it, I would have been taking 12 candies away from you. And last question. She has stacked books. Okay, her first book had a width of 4/7 and the second book had a... Really? Uh-oh, 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 uh-oh. Oh no. Oh, okay, so hang on. No, did my pen disappear? That's not cool. Here. Okay, here we go. So, here's a bookshelf. So you have a book, right? Here's a book. Maybe I shouldn't draw. Well, there's two books next to each other. One book, and I'm going to check the other book, right? So the first book, the width is 4/7. The second book, the width is 1 1/3. So they want to know what's the combined width. Really? That simple? Okay. So 4/7 plus the width of the second book. I'm going to change this. So I'm going to leave 4/7 alone. I'm going to change the second one to, yeah, let me change it to improper fraction. 3 times 1 is 3, plus 1 is 4, so it's 4/3, right? Now I'm going to find the LCM, which is 21. So both fractions change, so we got to find an equivalent fraction, right? So it's times 3 here, so it's times 3 on top, which is 12. 3 times 7 became 21, so it's times 7 over here. 4 times 7 is 28. Ready to add? 21. 12 plus 28 is 40. So if we simplify that, 21 goes into 40 one time, you're going to have 19 left over 21. Remember, if you don't know, if you forget how to do it, you can always just divide 40 divided by 21. 21 goes to 40 one time. You subtract 3, borrow, right? 10 minus 1 is 9. 3 minus 2 is 19. For this case, to change it to a mixed and proper mixed number, we leave it alone. So it goes in one time, which is my whole number, 19 left over, which is the numerator, over 21. Okay, that wasn't that bad. Okay. So that's it. Let me stop this. And oh, I already gave you one word, right? Please tell me that. And if I, so either of these two words will suffice as your bonus. So the second one is going to be, what's this? Bossa Nova. Okay.